Put down your fork, right now. Whatever you just ate or were about to eat, set it aside for a moment, because I want you to imagine something. What if you simply stopped eating for the next 24 hours? Not a calorie restriction, not a diet, a complete pause. No food whatsoever from this moment until this time tomorrow. Most people in the modern world have never done this voluntarily. They have been told by the food industry, by conventional nutrition advice, and by decades of breakfast cereal marketing that skipping meals is dangerous, that going more than a few hours without food causes muscle loss, that hunger is an emergency signal requiring immediate response. These ideas are almost entirely wrong, and the research that contradicts them, from the National Institutes of Health, from the Walter Longo Lab at USC, from the Intermittent Fasting and Human Metabolism Unit at the University of Copenhagen, is not preliminary. It is extensive, rigorous, and in some cases profoundly surprising. What your body does in the 24 hours after its last meal is one of the most extraordinary sequences in human physiology. It is a biological program that evolved over millions of years, during which food was never reliably available, and the human body needed to function, and function well, through periods of extended food absence. A program that activates repair mechanisms your body cannot access any other way. A program that most people in the developed world have never allowed to run to completion in their adult lives. Today I am going to walk you through exactly what happens, hour by hour. Because the 24-hour fasting timeline is one of the most documented, most misunderstood, and most consequential biological sequences available to you. And once you understand what is happening at each stage, the idea of going 24 hours without food will feel less like deprivation and more like what it actually is, one of the most powerful biological reset mechanisms ever identified. Before we start the clock, you need to understand the metabolic architecture that a 24-hour fast is moving through. Because every hour on the timeline makes sense only in the context of the fuel system it is transitioning. Your body runs on two primary fuels, glucose and fat. Glucose is the fast fuel, easily accessed, rapidly burned, but available in limited quantities. Your liver and muscles store glucose as glycogen, and the total glycogen storage capacity of the average adult is approximately 400 to 500 grams, enough to fuel roughly 12 to 16 hours of normal metabolic activity at rest, less with exercise. Fat is the slow fuel, stored in essentially unlimited quantities in adipose tissue, but requiring a different metabolic pathway to access, one that is suppressed when insulin is elevated. Insulin is the metabolic gatekeeper. When you eat, insulin rises. When insulin is elevated, glucose flows into cells, glycogen is synthesized, and fat cells are locked. Lipolysis is biochemically impossible when insulin is present. When you stop eating, insulin begins to fall. When insulin falls below a critical threshold, fat cells open. Lipolysis begins. The body begins burning the fuel it has been storing for exactly this purpose. The 24-hour fast is a journey from glucose dependence to fat adaptation, from glycogen-fueled to ketone-fueled metabolism. And the biological events along the way are not simply about fuel switching. They involve a cascade of hormonal, cellular, and neurological changes that researchers now consider among the most health-promoting sequences the human body can undergo. Hours 0 to 4. The clock starts with your last bite. For the first 4 hours, your body is in the fed state, digesting, absorbing, and distributing the nutrients from your last meal. Insulin is elevated. Glucose is circulating. Your cells are absorbing what they need, and your liver is packaging excess glucose into glycogen. Nothing metabolically unusual is happening. You feel full. This phase continues until digestion is substantially complete and blood glucose begins its post-meal decline. Around hour 3 to 4, blood glucose has largely returned to its pre-meal baseline. Insulin begins declining. If you were to eat again now, which is what most people in the developed world do, the cycle restarts and nothing beyond normal post-meal metabolism occurs. But if you do not eat, something interesting begins. Hours 4 to 8. Between hours 4 and 8, the body transitions from fed to early fasted state. Insulin continues declining. The liver begins releasing glucose from glycogen stores, glycogenolysis, to maintain blood glucose. Glucagon rises, shifting the machinery to release mode. Most hunger in this window is ghrelin-driven, the stomach hormone that rises in anticipation of habitual meal times, regardless of actual energy status. If you normally eat lunch at noon, ghrelin rises at noon whether or not you are depleted. This is habit-driven hunger, not physiological hunger. Most of the discomfort of early fasting is the body expecting food at a conditioned time, not the body running out of fuel. Hours 8 to 12. By hour 8 to 12, glycogen stores are depleting. Insulin has fallen enough that lipolysis is activating. Free fatty acids are entering the bloodstream. The fuel mixture is shifting from pure glucose to a blend of glucose and fatty acid oxidation. A 2016 study in Cell Metabolism confirmed the metabolic shift toward fat-dominant fuel use is measurably underway by hour 12 in most adults. The respiratory exchange ratio, reflecting which fuel is being burned, declines from the glucose-dominant value of 1.0 toward the fat-dominant value of 0.7. For most people, this window coincides with sleep after an evening meal, meaning the body quietly burns through remaining glycogen and arrives at fat-burning metabolism before waking. Hours 12 to 16. Hour 12 is where the fast begins to produce effects that no amount of food reduction can replicate. This is the window where ketogenesis, the production of ketone bodies from fat, begins in earnest. As glycogen stores approach depletion, the brain, which cannot store glucose or directly oxidize fat, begins accepting ketones as a glucose-sparing fuel. The subjective experience of this transition is one most fasters describe as a lifting of mental fog. A 2018 study in Frontiers in Molecular Neuroscience confirmed that beta-hydroxybutyrate upregulates BDNF in the hippocampus, offering a neurobiological mechanism for cognitive clarity. Growth hormone begins rising significantly. A landmark study at the Medical College of Wisconsin found growth hormone increased by an average of 1,300%. Growth hormone is powerfully muscle-sparing and fat-mobilizing. It signals adipose tissue to release fat for fuel while protecting lean muscle mass from catabolism. The fear that fasting causes muscle loss is directly contradicted by this hormonal reality. The body is protecting muscle while burning fat, through precisely the mechanism evolution developed to allow humans to function through food scarcity without sacrificing the physical capacity to find food. By hour 16, the body is deeply adapted to fasted metabolism. Ketone production is well established. Growth hormone is elevated, and a cellular process that cannot occur in any meaningful way while insulin is elevated has been fully activated. Autophagy. Autophagy, from the Greek for self-eating, is the cellular cleanup mechanism, the process by which cells identify, dismantle, and recycle damaged proteins. It is the body's internal quality control and waste management system, and it is the biological mechanism that has driven the most excitement in longevity research. Because of its documented connections to cancer prevention, neurodegenerative disease protection, and immune system renewal. Yoshinori Osumi won the Nobel Prize in Physiology or Medicine in 2016, specifically for his work elucidating the mechanisms of autophagy. The Nobel Committee's citation identified autophagy as fundamental to how cells maintain quality control and how disruption contributes to chronic conditions. This is not fringe science. This is Nobel-recognized cellular biology that fasting activates and that constant feeding suppresses. A 2019 study published in Cell Research measured autophagy markers, with significant elevation by hour 24. The cleanup crew was working at full capacity. Hours 20 to 24. In the final hours, the biological changes converge into a state researchers describe with language reserved for medical interventions. Systemic inflammation is measurably lower than at the start of the fast. A 2019 study in Cell found that fasting suppresses the NLRP3 inflammasome. The suppression was driven by beta-hydroxybutyrate, inhibiting the inflammasome's assembly. Ketones provide clean fuel while turning down inflammatory machinery. The gut is resting and repairing. Intestinal stem cell activity increases, gut barrier integrity is restored, and the microbiome shifts toward healthy species. A 2018 study in Cell Stem Cell found that extended fasting dramatically increased intestinal stem cell regenerative capacity, mediated by fatty acid oxidation. Insulin sensitivity is at its maximum. The prolonged period of low insulin has upregulated insulin receptor sensitivity in muscle and fat cells. When food is reintroduced, glucose will enter cells more readily, requiring less insulin for the same metabolic effect. This is a clinically significant outcome. Here is what I want you to carry out of this video. The 24-hour fast is not starvation. It is not dangerous for healthy adults. It is not causing muscle loss. It is a precisely documented, biologically specific sequence of events that your body has been designed to execute across millions of years of evolution. Hours 0 to 4, fed state. Hours 4 to 8, glycogenolysis begins. Hours 8 to 12, lipolysis activating, fat burning beginning. Hours 12 to 16, ketogenesis underway. Hours 16 to 20, autophagy fully activated. Hours 20 to 24, inflammasome suppression, gut repair. This is not a diet. It is a biological maintenance program, one that your body is ready to run the moment you allow it to. When was the last time you went 24 hours without food? Drop it in the comments. And subscribe to the channel, because next week we are going deeper into the specific fasting protocols the research supports most strongly. And I will see you there. Goodbye. See you in the next video on the biological journey.